Today we're going to be talking about solving systems of equations using elimination. So I've already shown you guys how to solve by graphing and substitution. So now we're going to use elimination. So here I want you to highlight the definition. To solve a system of linear equations by elimination, we're going to add or subtract the equations to eliminate one of the variables. So it says you may first need to multiply one or both of the equations by a constant so that one of the variables has the same or opposite coefficient in one equation as it has in the other. So go ahead and highlight this definition. Now, just like last time, you guys have an example written on your paper, but I'm going to go ahead and work, or you actually have two examples on your paper. I'm going to actually work two problems from the worksheet. I'm going to work problem number 5 and problem number 10. And once I work those two, we're going to finish the rest in class. So let's look at problem number 5. Okay, you have two equations, 4x minus y equals 6, and 2x minus y divided by 2 equals 4. Now, I know you guys hate working with fractions, so before we even get started using the elimination process, let's go ahead and rewrite the equation for number 2 so that we don't have to work with fractions. So what can I multiply everything by in order to get rid of the fraction? You should have said the denominator, which is 2. So I'm going to go ahead and multiply everything in the second equation by 2. So again, I don't have to work with a fraction. So my new equation becomes 4x minus y is now equal to 8. So we're going to use these two equations, the ones that I'm boxing in pink, to use the elimination process. Okay, so let's go ahead and rewrite these equations. We have 4x minus y equals 6, and I have 4x minus y equals 8. Okay, now what it told me to do in the definition was that I was going to choose one equation or both to multiply something by in order so that I can get rid of or eliminate a variable. So here's the example. What can I multiply this second equation by in order to eliminate my x values? That's right, you should have said -1. If I multiply everything by a -1 on the second equation, when I end up adding them, look what's going to happen. So my first equation did not change, so I'm going to rewrite the equation. My second equation now becomes -4x plus y equals -8. Now what it tells me to do is that I'm going to either add or subtract my first and second equation. Well, because there's a minus sign right here, I'm going to end up subtracting them. So look what happens. I have 4x minus 4x. Those cancel. But look what also happens to my y variables. My negative y and my positive y are going to cancel. So all I'm left with is that 6 is equal to a -8. Now, just like we did on substitution when I had two numbers that were equal to each other and it was a false statement, what word was my answer? That's right. It should have been no solution. So you're going to see that something similar using elimination, that we could still have answers that are no solution and infinite. Okay, now let's look at question number 10, and this will actually give us a coordinate point so I can show you one of those. On question number 10, we have 5x plus 4y equals 12, and we have 7x minus 6y equals 40. So again, we're going to choose a variable that we can eliminate. It doesn't matter whether it's x or y. So this one I'm going to actually choose to eliminate y. So in order to figure out which number you're going to multiply by, the easiest way to come up with it is if I find the variable that I'm going to eliminate, and I said y, we have a 4 and we have a -6. I can actually multiply those two together. That gives me 24. So what number do I need to multiply this top equation by in order to get 24y? You should have said 6. And let's look at the second equation. What number do I need to multiply by in order to make this a -24? That's right, you should have said +4. We want one of the equations to be negative and one to be positive so that when we actually add them together, they get eliminated. So now I'm just going to multiply everything by 6 on the first equation and 4 on the second equation. So when I rewrite it, I have 30x plus 24y is equal to 72. And my second equation becomes 28x minus 24y equals 160. And now we're just going to add them together. So what happens to my y's That's right, they're going to cancel. So all I have left is 58x is equal to 232. And then we just solve. So I'm going to divide both sides by 58. So what you should have for x is that is equal to 4. So just like we did on substitution, now that I've found my x variable, what do you think I need to do in order to find my y? That's right, I'm going to plug it back in. Do you think it matters which equation I choose to plug it back into? You're right, it doesn't. So if I plug it back into 5x plus 4y equals 12, I have 5 times 4 plus 4y equals 12. I have 20 plus 4y equals 12. If I subtract the 20 from both sides, I end up with 4y equals negative 8. Divide both sides by 4, and my y is equal to a negative 2. So when I ask you for the solution, your solution you're going to write is the actual coordinate point. So the answer for number 10 is 4, negative 2. That coordinate point is where these two graphs intersected. Now another way to check it is graphing. Solve both equations for y, plug it in the calculator, and make sure that they intersect at 4, negative 2. So again, you guys are going to work the rest of the questions in class. Hope you have a good weekend.